Our Sun, a 4.5 billion-year-old yellow dwarf star, serves as the vibrant core of our solar system. Located approximately 93 million miles, 150 million kilometers, from Earth. Without its radiant energy, life as we know it would cease to exist on our planet. Despite its seemingly unchanging appearance from Earth's perspective, the Sun is a dynamic celestial body, continually emitting energy into space. The Sun. As the largest entity within our solar system, the Sun boasts a diameter of roughly 865,000 miles, 1.4 million kilometers, exerting gravitational forces that maintain the orbital stability of celestial bodies, from planets to minute debris. While the Sun occupies a central role in our solar system's dynamics and sustains life on Earth, it stands as merely an average-sized star among its stellar counterparts. Some stars discovered exceed its size by up to 100 times, and numerous solar systems feature multiple stars. By scrutinizing our Sun, scientists gain valuable insights into the mechanisms governing distant stars. At the Sun's core, temperatures soar to over 27 million degrees F, 15 million degrees C, rendering it the hottest region. Conversely, the photosphere, often regarded as the Sun's surface, registers a comparatively cooler temperature of around 10,000 degrees F, 5,500 degrees F. However, a notable enigma surrounds the Sun's outer atmosphere, known as the corona, which inexplicably becomes hotter as it extends farther from the surface. The corona's temperature can reach up to 3.5 million degrees F, 2 million degrees C, significantly surpassing the heat of the photosphere. The life cycle. Approximately 4.6 billion years ago, the Sun was born. Many scientists believe that the Sun and the rest of the solar system formed from a giant rotating cloud of gas and dust known as the solar nebula. As this nebula collapsed under the force of its own gravity, it spun faster and flattened into a disk, with most of the material being drawn toward the center to form the Sun. The Sun possesses enough nuclear fuel to maintain its current state for another 5 billion years. After this period, it will expand into a red giant. Eventually, the Sun will shed its outer layers, and the remaining core will collapse into a white dwarf. Over time, this white dwarf will slowly fade and enter its final phase as a dim, cool, theoretical object known as a black dwarf. Internal structure and atmosphere of the Sun. The Sun and its atmosphere are composed of multiple zones and layers. The solar interior consists of the core, radiative zone, and convective zone. Above the interior lies the solar atmosphere, which includes the photosphere, chromosphere, transition region, and corona. Beyond the corona extends the solar wind, an outflow of gas. The core stretches from the Sun's center to about 1/4 of the way to its surface. Though it constitutes only about 2% of the Sun's volume, it is nearly 15 times denser than lead and contains almost half of the Sun's mass. Surrounding the core is the radiative zone, extending to 70% of the way to the Sun's surface. This zone makes up 32% of the Sun's volume and 48% of its mass. Within this region, light from the core is scattered, often taking 1 million years for a single photon to pass through. The convective zone reaches up to the Sun's surface, comprising 66% of its volume, but only slightly more than 2% of its mass. This zone is characterized by turbulent convection cells of gas. There are two primary types of solar convection cells: granulation cells, which are about 600 miles, 1,000 kilometers wide, and supergranulation cells, which span approximately 20,000 miles, 30,000 kilometers, in diameter. The photosphere, the lowest layer of the Sun's atmosphere, emits the light we observe. It is about 300 miles, 500 kilometers, thick, with most of the light emanating from its lowest third. Above the photosphere lies the chromosphere, which is hotter, reaching up to 35,500 degrees, 19,725 degrees C. This layer is composed of spiky structures known as spicules, typically around 600 miles, 1,000 kilometers, across and up to 6,000 miles, 10,000 kilometers, high. Next is the transition region, which is a few hundred to a few thousand miles thick. This region is heated by the corona above it and emits most of its light as ultraviolet rays. At the top of the solar atmosphere is the superhot corona, consisting of structures like loops and streams of ionized gas. The corona's temperature generally ranges from 900,000 degrees Celsius, 500,000 degrees Celsius, to 10.8 million degrees Celsius, 6 million degrees Celsius, and it can reach tens of millions of degrees during solar flares. The corona continuously releases matter in the form of the solar wind. Did you know helium got its name from the Sun? When scientists first tried to determine the chemical composition of our star by analyzing its spectrum, they encountered radiation lines from an unknown element. Initially believed to exist only in the Sun, this mysterious element was named helium, after Helios, the Greek god of the sun. It wasn't until later that helium was discovered on Earth, but the name persisted. Helium constitutes about 24% of the Sun's mass. Hydrogen, the most abundant element, makes up approximately 73%, while the remaining 2% consists of heavier elements like carbon, oxygen, and iron. The energy produced by our Sun is the result of thermonuclear fusion reactions occurring in its core, where hydrogen nuclei are fused into helium. This process releases a tremendous amount of energy, which radiates outward and provides the light and heat essential for life on Earth. Understanding the Sun's composition and the processes occurring within it has been fundamental to our broader comprehension of stellar life cycles and the dynamics of other stars in the universe. The photosphere. The Sun doesn't have a solid surface like Earth and the other rocky planets and moons. What is commonly referred to as the Sun's surface is actually the photosphere. The term photosphere means light sphere, which is fitting because this is the layer that emits the most visible light, making it the part we see from Earth. It's crucial to remember never to look directly at the Sun without proper eye protection. Although we call it the surface, the photosphere is actually the innermost layer of the solar atmosphere. It extends about 250 miles thick and has temperatures reaching approximately 10,000 degrees Fahrenheit, 5,500 degrees Celsius. While this is much cooler than the Sun's blazing core, it is still hot enough to cause carbon-based materials like diamonds and graphite to not just melt but boil. Most of the Sun's radiation escapes outward from the photosphere into space. The Sun's magnetic field. The Sun's magnetic field is generally about twice as strong as Earth's magnetic field. However, it can become highly concentrated in localized areas, reaching strengths up to 3,000 times greater than usual. These intensifications occur due to the Sun's differential rotation. The Sun spins more rapidly at the equator than at higher latitudes, and the inner parts of the Sun rotate faster than the surface. These distortions in the magnetic field lead to the formation of various solar phenomena, ranging from sunspots to dramatic eruptions such as flares and coronal mass ejections, CMEs. Solar flares are the most violent eruptions in the solar system, while CMEs, although less violent, involve enormous amounts of matter. A single coronal mass ejection can release approximately 20 billion tons, 18 billion metric tons, of matter into space. The Sun's immense mass. The Sun accounts for 99.866% of the total mass of the solar system. This means it weighs about 500 times more than all the planets and asteroids combined. Even Jupiter, the largest planet, has a mass that is only 1,000th that of the Sun. In comparison, Earth is approximately 333,000 times lighter than the Sun. The Sun's vast interior could accommodate about 1.3 million Earth-sized planets. Despite its enormous size, the Sun's density is about 40% greater than that of water. Sun's crown. Ever heard about the Sun's crown? The Sun has an outer layer called the solar corona, which translates to crown in Latin. This fascinating part of our star is made up of protuberances and various plasma eruptions that often extend hundreds of thousands of kilometers, far longer than the distance from Earth to the Moon. The solar corona is one of the hottest regions of the Sun, with an average temperature between 1 and 2 million degrees Kelvin. Remarkably, some areas within the corona can reach temperatures as high as 20 million degrees Kelvin. This intense heat and dynamic activity make the corona a constantly changing and intriguing aspect of the Sun. Although the corona is difficult to observe from Earth due to the Sun's overwhelming brightness, it becomes visible during a total solar eclipse. When the Moon completely covers the Sun, the corona appears as a glowing halo around the darkened solar disk, offering a rare and spectacular opportunity to study this crown of the Sun. Sunspots and solar cycles. Moving forward, we encounter the fascinating concept of sunspots and solar cycles. Sunspots are relatively cool, dark areas on the Sun's surface, often appearing as roughly circular spots. These features form where dense bundles of magnetic field lines from the Sun's interior break through the surface. The number of sunspots fluctuates with the Sun's magnetic activity, a phenomenon known as the solar cycle. This cycle, which averages about 11 years, sees the number of sunspots increase from a minimum, often none, to a maximum of approximately 250 sunspots or clusters, and then decrease back to a minimum. At the end of each cycle, the the Sun's magnetic field rapidly reverses its polarity. The Sun's changing activity. The Sun's activity undergoes periodic fluctuations, with sun flares occurring sporadically and unpredictably across its surface. Despite the lack of certainty regarding when specific sunspots will erupt, there appears to be a certain rhythm to the overall number of spots. These fluctuations follow regular 11-year cycles, each comprising a maximum and a minimum. Currently, we are in the 25th cycle of solar activity since the beginning of observations. Scientists anticipate the next peak of solar activity to occur in 2025. However, the underlying cause of this periodicity remains unknown, and it is unclear whether the period of these fluctuations changes over time. The finite era of total solar eclipses. Lastly, the occurrence of a solar eclipse, wherein the moon passes between the Earth and the Sun, obscuring the Sun either partially or completely, is a captivating celestial event. Despite the expectation of experiencing a solar eclipse every 29-30 days due to the lunar phases, the actual frequency is limited to 2 to 5 times a year due to the moon's inclined orbit relative to the plane of the ecliptic. Total solar eclipses, where the moon completely obscures the Sun, are particularly awe-inspiring. Additionally, partial and annular eclipses occur under varying lunar positions, such as when the moon is in the far part of its orbit and its disk appears too small to cover the entire Sun. However, the era of total solar eclipses is not eternal. In approximately 600 million years, these spectacular phenomena will cease to occur. As the moon gradually moves away from Earth, it will reach a distance where its apparent size will always be smaller than that of the Sun, resulting in the observation of only partial and annular eclipses.